Thank you. Good afternoon, everybody. I know this is probably your last session, and I know that someone gave me 60 minutes. I will try not to use them all. Very well. My name is Daniela Braga, and I'm the founder and CEO of The Fine Crowd. I'm not here to talk about my company, but the fact is my company is that's what we do. Through data, we are a data platform that creates high-quality training data for big enterprises, and we're all about fighting bias in machine learning algorithms. So there will be a bit of talking about my company too, but most of it is talking about my almost 20 years of experience in the AI space. I have a research background, PhD in speech technologies, and background in linguistics as well. Microsoft found me back in the early days in 2006 in Portugal when they launched the development center there, and it was the early days of what came later to be Cortana. I was involved for 7 years with the speech at Microsoft Group around the world, from Portugal to China to the US, and responsible for language expansion at the latest part of, in my latest days in Cortana. I also have published almost 100 papers, so there is a combination of academics with product. And with all the money in the world back in the days at Microsoft, I realized that there was a problem that we couldn't solve, which was quality of data, consistency, and balance. And so that's how I started this company, and I'll have 3.5 years ago. Our history is also connected with Microsoft later. We went through their accelerator in AI in our early days in 2016. And we're now a co-sell partner and being in display in the startup gallery over there. So it's been an interesting, long journey. I'm going to talk about bias in AI. How does it happen? Why does it happen? And how can you prevent it? And today, I'm sure, we all heard about it. The press makes sure that every time someone screws up, it comes on the news. There's usually no intention whatsoever to cause any of that. But essentially, it's when an AI, what is bias? It's when an AI or machine learning model produces a non-accurate, an erroneous prediction that obviously impacts some social group or some ethnic group. And of course, our goal as machine learning AI technologists and researchers is to understand how can we prevent that, because most of the times it's really it's not intentional. And we all heard about AI going bad in examples like this. We heard a few years ago, Google had huge press on their image labeler that was identifying black people as gorillas, and the system was shut down immediately. We recently heard Amazon having a big issue on predicting or showing jobs that are traditionally male-oriented, tech jobs for male candidates, again, another. And we also heard about Microsoft Day, that lasted a few hours, an incredible research project from Microsoft Research that also got shut down a few hours later because it was using the learning of people tweeting back racist comments. So this all can really hurt a brand. It can make lose customers and non-trust and make the brand not be trusted. it can not, of course, it can discard a whole segment of population that you actually want to have as your clients or customers or target. So, and the reality is, that's why data is so important in especially, and data scientists are trained to learn the latest technology, the latest techniques to learn machine learning and to build machine learning models from scratch or use services out there, but they don't learn how to make their data sets non-biased. So basically, why does bias occur? And it occurs basically in the same way as we humans learn information. If you are raised in a place and you never leave the place and you interact with a few limited group of people and you have limited access to information, when you're exposed to something new that you've never seen or you've never done, you will react based on the information that you have learned. It's the same thing with machine learning models and with AI. You essentially are going to feed the data and the information, and the more or less, and the more balanced that the data set is, the better prediction you can expect. But it's not that simple because it's actually has to do with a lot more than that. And in fact, it can happen. It happens mostly in this point. So first of all, when you're designing a model, an AI model, you have a particular goal. You want a prediction. You want your model to respond in a certain way. You even define what the accuracy could be. Then you start the data collection process, which is this working, I guess? So you start the data collection process, and that's where every bias problem starts, which is in the second phase. Essentially because you're focusing getting your model trained on the latest version and more deep learning, more neural networks and more variants and more values, but you're not looking at the specification of the data. And who designs the data oftentimes also does not account for the usability of that model, which is a fair statement. Are scientists that have a different purpose and a different goal. So bias gets introduced in the data collection process right away by the way you source the data, by the diversity of sources that you get. And I'm being very generic, and I'm going to be more concrete, especially in the fields that I work with and our clients work with, which are the fields of cognitive services. So everything in the speech technologies, natural language processing, and computer vision area is what we work with. It's really the same thing across any AI prediction, whether you're predicting when your coffee machine is going to break or when you're going to predict results from Cortana or speech recognition, or from when you feed product reviews of your product into a cognitive service that will produce sentiment out of it, and you have an idea in real time of how your product is performing. So data collection and limited contributors, so that's the problem. And contributors meaning real people. So we, in the way we collect data, we use crowdsourcing. We bring people to the loop. We gather millions of inputs from people all over the world, and we segment the population. So that's, and more than segment, we even sometimes target groups that are misrepresented in the data set, especially when we are improving a model that is already there, trained with which is a classic example of trained with white male data only. So then, when you're preparing the data, you are going to pick attributes of those contributors. That will be age, gender, dialect, location, type of device they're using. So all of this information, also the way you pick it, and the types of things that will matter to your model will introduce bias. So you continue adding bias or not. Then you train a model, which already carries all this information. You ship it to an AI application, and in the testing phase, again, oftentimes you use the same source. You're not the same set, but the same source, meaning the same type of vendor or the same type of way of collection or the same type of users if you're training it with user data. So then traceability is another problem. Figuring out which version of the model had that particular data set that was introducing the bias this is when things get messy and complicated. And why is it hard to fix? Well, it is hard to fix because, again, oftentimes people don't keep track of the version of the models where certain types of data were introduced. Because a lot of times the sources of the data are the same, so there's not variety enough there. The models picked are not versatile. You're picking sometimes a too simple technique to address a complex data set, or vice versa. That is also a problem. Not only the data, but the type of technique you're picking in the AI training is important to handle the right amount and the right variant of data. And fairness, which is a subjective topic. Fairness doesn't go, subjectiveness of what is fair in the results of the model doesn't go along with mathematical results that are objective, right? So all these things are difficult to make sense. Well, we all know that training data is a vital component. Everybody building machine learning models and AI knows the importance of data and how difficult and time-consuming this is. Again, like I said, I started this company because of that problem, because we all wanted to ship products and make the world, create a better world, but there's this messy, complex, not sexy at all problem of data that handles that basically the inconsistent and bad, poor quality, the speed of acquiring data, which also was a big deal, especially when you are in competition with another big company, and scalability. You want to go to other markets, and you have to source and start from scratch and even explain to the local vendors what you're trying to do. A lot of times, compromises are made in order to get faster to market, and that's, again, when oversighting the speed versus the quality of the data, it's, again, where bias happens as well. Now, how do we solve this problem? So first of all, three things, actually. The diversity of data sources, and in this case, in our case in particular, of contributors. So we do source our data from, like I said, crowdsourcing, from the wisdom of millions of people all over the world that speak local languages, that have cultural knowledge. Again, we're talking about cognitive services, so language component is very important. But it can be also pictures. We are helping companies develop better machine learning algorithms for camera companies to have you take better pictures and understand what is a better picture, or understand in robotics, objects around you, what they are, whether you talk to them, whether you actually assist people, and that's very common in Asia, actually, customer service. And with aging population, you see more and more robots replacing humans in customer service. So the diversity of contributors, segmenting the population by region, by dialect, by gender, by age, when you're bootstrapping a model, that's one of the things we do. And all the metadata that comes with every individual still respecting GDPR, that's some of the things we do. We also know information about the contributors. We know that they worked before in the system, that they performed well with the system, that they did not spam. We paid all these people. So whenever there's money involved, there's spam. So there's a lot that we train machine learning to detect spam. But we also understand their performance, their behavior, their accuracy, and where if they're better at certain tasks than others. So that's one of the ways of going about this. And it involves thousands of people. That's the other thing, thousands of people. The other thing around creating more fairness is balance of data sets. So this is the typical, I'm sure some of you have heard about the dilemma of the variance versus bias dilemma, which is basically whether if you collect, and this is on the data, but it's also on the modeling in this case. You have, let's see a case of the typical cases in speech recognition in your car. You're driving around, you ask your car whether it runs Siri or Alexa or Google Assistant. You ask your car for directions, and they don't understand you, or the car doesn't understand you. This is a typical case of non-balance, or basically underfitting in the model. So when you have data that is skewed to what is the generic population, considered generic population or users, but then doesn't account for dialect change, for sociolect change, or for even circumstantial change, like noises, different noises, or we do oftentimes collections in India, in the middle of the city, with all the noises of the city. We do data collections in houses, in homes, simulating environments at home, with people and multi-talking and kids in the background, because all of those are the reality of the users. But we also do collections of Southern dialects in American English because they are not represented in most of the data sets. Now, the overfitting is when, for example, you train a model with voices from United States and from the UK and from Australia and from New Zealand and South Africa, and you put them all in the same bag, and you train a model with that. That's going to give you a lot of possibilities whenever a new person comes in, which probably utters one sentence, and it's hard to place it in so much of the variability of the data set. So again, deep neural networks work better there. So if you're building a huge model that has to handle something like that, that's why deep neural networks exist. But oftentimes, researchers and clients opt to ship model for American English, a model for UK English, a model for Canadian English, and just deliver it in those markets and not mix the whole data set. So to precisely avoid overfitting. So there's all these things to consider in the balance. And finally, accuracy. And defining accuracy in data is different from defining accuracy in models. Not necessarily, sometimes it's the same thing. For example, again, with the same example of speech recognition, word error rate is the accuracy measure for speech recognition, and it's also the accuracy measure for collection of voice, at least in scripted voice. But if you look at image, for example, you're going to look at pixelation, of resolution, at blurriness, at elements in the picture, making all of this. The accuracy definition is going to change. Or you go to text or to translation, and what is the definition of a good translation? You start having subjectivity. So definition of accuracy in data is something we have been building standards for, because it's difficult and because you need a lot of experience in managing all these types of data sets. We right now support more than 70 types of data workflows, which basically means you put a request on I have a demo for that, and you can have a request for a data unit type, massive one. It needs to be, it's usually in big scale. And it goes through a pipeline of different steps, and there is analytics before and after to walk you through what is the definition of accuracy in each data set. So again, accuracy has to do as well with looking at median and average typing speed. So there's a combination of other things we do. We look at qualification of the crowd at the language level, at the job level. We look at the time they spent on the task, of the percentage of actually correlation to precision and recall against the goal sets that we define, and the number or percentage of tasks that were abandoned on the way. And again, quality is better than quantity again, and it's also related to the technique of machine learning you're going to. So you need to, there's a correlation between the type of data. If you have a smaller data set, you're going to obviously look at a simpler technique of machine learning. You would be surprised. It seems obvious, but it's not obvious. A lot of times, people use more complex techniques, but very small data sets which skew the results. And again, they don't oftentimes create systems of what we call metric controls, goal sets, real-time audits, and other metrics to compare to what we call ground truth, to define ground truth in data, and keep track of the performance of the contributors in the task. So some of the things we do at Define Crowd are in these three pillars, basically. One is around the contributor quality. So like I said, we do check their existence, their account. We have spam detectors that prevent multiple accounts creation. There are techniques for that correlate with payment forms and so on. We'll look at their language skills, and we assess that, and their qualification on the job after the language skills. We'll look at, we have a whole set of anti-spam detectors, and we build a reputation system and a performance score per individual. So there's the crowd contributor part first. Then there's the data piece. And the data piece is, again, we define what exit criteria is per unit, and we have a system of metrics against that I described before that are different per data unit. And then there's the task, there's the task quality itself. So we look at the usability experience. The way you elicit the task to the user, to the contributor, affects the quality of the data. If you are a Thai speaker and you are working and you need to execute entity tagging or information extraction in Thai, but you're getting a task in English, you're going to absolutely have bias already in the way the task is elicited. So there's a lot of psychological studies around things like that. And so all of these things are very well thought at the Fine Crowd. And there's other practices, of course. The obvious ones is analyzing the data. And a lot of times, when you control the data collection phase, it's easier. The problem is when a client has user data, and they don't know what they have. And they have very little metadata information from that user data. So that's when things get complex. And then is where there's labeling and annotation of that data that needs to happen, and even the process of selecting and extracting has a whole randomization technique that needs to be applied. Then you test and test your models and iterate. And you should iterate in phases. So always iterating, even after, of course, shipping it. And finally, monitoring and updating your deployment and creating a feedback loop of continuous improvement of the model with real user data. That also needs to be labeled, so you're not introducing more bias into your model that is already there and probably has enough of the data that you're getting in the first phase, for example. Well, a little bit about us. We started in late 2015. We're a Seattle-based company. We have offices in Europe, in Portugal, and in Japan. We are opening 2 new subsidiaries this year, one in India and one in China. We have, in terms of FTEs of the Fine Crowd, it's a product company, so 2/3 of the company is product, machine learning, and engineers. We have been growing 600% every year. We've done rounds of funding and the venture capital fund. We raised $13.1 million so far in the beginning of the 3 years. Probably raising another round this year, a big one. And we have been, our clients are Fortune 500 companies building AI systems and in multi-market footprint. So this is usually our best fit. It's big data, big scale, global, multilingual. And we have been, our value proposition has been the same. Nothing changed so far. We've been fighting the challenges of poor quality, slow speed, and scalability by being the only company in the market really ensuring and assuring SLAs of quality, 95% or more per unit, per data unit, with an unmatched speed. What used to take me 2 years, product life cycle, for example, at Microsoft to ship a product, now we can do it in 3 months with 10 times more data with our technology. And we support 50 languages across 70 countries with the exact same methodology. So if you're a brand and you want to go some other country, you may rest assured that the type of data quality you have in United States is exactly the same you're going to have in Germany. How do we do this? We combine crowdsourcing with machine learning. We bring machine learning to work alongside people and make their work more productive and control their quality. We don't train models for clients. We train models for our own productivity and our data production productivity. And what we do is basically anything from collection to structuring to testing across all these languages that you see here. And with a crowdsourcing community called Nivo that has been growing about 3 times a year. It's not so much about the number, it's about getting them stick and qualified and doing a good job and engaged. So, a little demo about us, and so how does that work? We have 2 sites in our product. We have an enterprise portal and a crowdsourcing portal, which is Nivo. So in the enterprise portal, let's say you're going to, let's say, I don't know how many of you saw the Vision keynote yesterday and all that super cool conversational speech recognition, real-time transcription system. Exactly. Well, I have to tell you something. That is super difficult with that latency and with that word error rate accuracy. It's incredible to see the work that the team has been doing over these years to get to that conversational level. In any case, if you need, let's say you are a car automaker and you are taking that piece on your hands, mostly because it's client's data that you own and you can't touch it, but you still need to develop your own speech recognition that on top of it, it's not tuned for tech jargon, it's tuned for people navigating across different countries and that have interests in media and sightseeing and getting to places. So you would come here and select our speech collection workflow. There's several types. This is a scripted one. You select the language option. You see there's a big drop-down of language list. You can only launch campaigns per language because if you think about it, every time you go to a different market, you need different language qualification. So that's why you have to launch you need to launch different campaigns according to the language. You selected United States and English, and next you're going to define the age range of your contributors, and you're going to define how many contributors per prompt. This is just a quick demo. We oftentimes launch these campaigns with 5,000 people. You don't want to do that either because you want to iterate. So you want to launch 100, 100, 100, and when you're more confident, then you launch 5,000. So you need to iterate your model. So this shows you different environments, desktop versus mobile. You can pick both as well. Also shows you bits per sample, also shows you sampling rate. And then there's a description of what you should say, how you should say, where you should be when you're doing the recordings. This, in the Nivo side, makes you download an app on your phone and record sentence by sentence. That's really how it works. Now, conversation is one of the workflows we provide. It's a different thing. We also provide that. You call a number, it pairs you with another person that plays the role of an agent, and you have a directed customer service domain-specific conversation. And that's the way most of our clients go to precisely avoid overfitting. So they specify a domain, and they launch a model in a banking domain or an insurance domain or a healthcare domain. then you do, this is a workflow. You do a data collection part, and you need a validation part. So you have audio. This is all set up at the first time, but in the actual real time, you have one task doing voice collection and another task doing validation of the audio against the script, which is what is being defined here. Then you can define inter-annotated agreement. 2 out of 3 should agree on the result. You continue, you introduce qualification tests. This is a task for which we create the ground truth. These are the instructions that go actually to the crowd. On the Nivo side, you're going to see things like you're gonna pick a template, a task that you will the platform will show you if you qualify for. If you don't qualify for, you have to go through a language test and then through an actual qualification test for the job. And it basically shows you. Sorry, oops, that's this one. It shows you. Play. It shows you a task that asks you a yes/no question on an audio file and a transcript, and you have to verify if yes or no the audio matches the script. This is one of the many types of tasks we do in big scale and multilingual for a lot of our clients. Well, thank you very much. I hope we still have some 20 minutes, 23 minutes, and I can take questions now. I guess you have to ideally go to the mic to ask the questions so we can get your voices in the recording. Otherwise, I can say it out loud and answer. Again, we don't do any AI. We do the cognitive services piece, which is a little trickier, but it applies to everything.
Can
you introduce yourself, please?
I'm Yenene from Starbucks. I'm a data scientist. So I have 2 questions. The first one is the data quality and the fairness. Because if you have a control of how to collect the data, that's easy. But sometimes you use historical data, which you don't have much of a control, but have a bias which is built in historical data, and you don't want to throw away. Because, and how you get that fairness and quality into the process.
And that's a very good point.
The second question is related to the data, and then you're saying, as a data scientist, you train the model, and traceability is important. I mean, you want to trace what leads to the decision or your algorithm to make a decision. So in that sense, it's not only the model, and you have to tag your data. And if your data are in petabytes, how you keep that version if you have generating hundreds of models, how that tagging gonna be?
That's thank you. So on the not throwing away data, absolutely, we should never throw away data. Also because we need to train models with the bad data too. We just need to label that data, either bad or good. We have to have a labeling system of the data to expose it to the model training. So even if you have, and the challenge is when you have user data and you have no idea of any type of classification on it, which is why you have to put it in a service like ours, which handles that kind of data at large scale and very fast. So right now, before you had to take a look here and there and a spot check, that's no longer the case with a technology like ours. You can actually handle large amounts of data in a very short time and get them labeled and even get them thrown away semi-automatically, because the way we build our models, our data sets, is also assuring balance when you know nothing. So we also train models to start predicting what could not be the type of class that you want to have in your model. So the other question was, oh my gosh, the other question was about what do you do with the versioning? It's the same problem with the versioning of models, but the versioning of data is a nightmare. That's where data lakes and data architects and big DBAs come in any organization. And we have the same problem, to be frank. We deal with so much amount of data that we had to redo. We are on Azure. We have very good engineers, and we had to redo our architecture at least twice in 3 years. This is the reality. So when things that's the reality of our data world. Because of scalability, because of latency, because of all those things. So the model training and the versioning of the model is another big issue. Keeping track of the model is not that simple too, especially when you have parallel models in flight, which is what also happens when you run a large product and you ship it in many different markets. More questions? If you don't mind coming to a mic, thank you.
So I have
and
one
introduce
question.
yourself.
How do you combine two unrelated data sets? So, for example, you have a demography and you have a survey, but you want to find some insights. How do you horizontally extrapolate the data set? Do you have any techniques, or do you?
Sorry, you need to speak louder, sorry.
Okay. So, imagine there is a scenario, you have two different data sets. One is probably the demography, and another is a survey about that demography. So there's one is 10 million and maybe another few thousands. How do you horizontally extrapolate these data sets if you do? So when you do, what are the parameters you check before and after merging these data sets to make sure they are fine?
So let me see if I, don't go away, because I'm not sure if I understand the question from here. So you have different types of data sets that you want to combine in the same model, right? And how do you make them make sense in the same model? Is that the question?
Yeah, how do you make sure the data set is right before and after? So what are the parameters you check?
Which one is?
So for example, distribution of the data, like that, what are the parameters you check before and after extrapolating the data sets?
Extrapolated data sets. Well, one thing we do as well, and maybe that, and I hope that's what you're looking for. We simulate data that doesn't exist. Yeah. So which is a good way to extrapolate. Well, to extrapolate with a valid basis without the data actually have been created. Yeah. The challenge here is when we're going to creating algorithms for mortgage prediction that don't have data with females. That's one of the classic examples. Or the whole thing around basically in the legal area of predicting whether someone can be a criminal again with the data set that exists. So that kind of data, I think using theoretically the same process we use, it's possible to generate, or creating rain in California, which is the easy example. But in our world of cognitive services, you actually can simulate events and classes of data that were never created using crowdsourcing and a combination of machine learning techniques that create data that never existed. And so that's now one of the things we do, and a lot of the world is doing to precisely prevent that kind of bias.
But how do you verify before and after some sort of
data part? Well, there's a lot of pre-processing techniques before and after, that's not machine learning. These are things that, for example, avoid duplicates in the entry, in the beginning and in the out.
No, I'm not asking about that. So for example, if there is a distribution about what one feature before you generate those data or simulate the data, so after you simulate the data, do you cross-verify the distribution of the same parameters or something like that? So what are the validation steps you do after simulating the data?
Because there's always a validation step. So in the data collection, when we're doing data collection, there's always a validation step that makes sure that metadata, for example, of gender or location is valid. So there's a validation step. We don't take for granted just geolocation or just information from the profile of the person. We validate it using another human step or combination of human and tools. And in the labeling steps, there's verification by multiple people, so internotated agreement, and each individual has a performance score that is given by blended in real-time audits, the way we call them, which is questions for which we know the answer that they get without knowing that they are actual questions or tests. So there's different techniques in different stages, collection versus labeling classification, that have been shown to be very powerful and very accurate. And of course, then you stipulate an F score, F1 score, and precision and recall value, and all of that needs to be checked and determined.
Alexandra, Microsoft research engineer. So I had a question about this slide about how data sets can create features. Oh, it can create fairness, and specifically there were notes which I did not understand. If we could maybe go back to the slide, maybe it would be easier.
One of the fairness slides, right?
Yeah, I think it was the first one. The notes were about number of tests passed, failed, device, and jobs completed. Could you give some more
I think I know what you're saying. Let me get back to that one. Is it this one, maybe?
In the bottom, the
number of jobs completed, right?
Uh-huh.
Yep. Mm-hmm. So because the number of jobs completed that are successfully completed gives you another piece of information about your contributor that gives you more trust. So we actually we have a whole algorithm to understand individual performance and how much we trust each individual, because it's not just about applying internotated agreement. That contributor needs to have in the reputation system needs to have a high score. So it's one of the techniques we look at. But we look at also percentage of tasks that are failed or passed historically and against their peers. When a new thing is introduced in a new framework, that doesn't, just because someone fails doesn't mean that, but historically has a good track record doesn't mean, it's probably because it's a new framework, the guidelines need to be reviewed, and we're not, and it's not, the task is not elicited correctly, so that's why we go a lot in iterations, also in the usability of the task itself. And we also look at click-through, how time spent on task, and all the variation in the peer group and in the language. So it's one of the things we look at, and understanding knowledge about the performer, or the contributor.
So what is exactly job and what is test, and what do device have?
So we define job as a task. And it's a job for Nivo, it's a task for the client. So the client defines tasks, but the contributors in Nivo receive them as a job, right? And the tests are for the contributors. So the tests are specific for, first they have a language side of it, which can be on the writing side or on the understanding or on the production side. And there's an actual job test, because a lot of people are great at doing sentiment analysis or recording voice, but are not good at understanding differences in semantics of, for named entity extraction, for example. So this type of things, not just because we are native speakers of a language, doesn't mean that we're good at all these types of skills. And some of these skills we handle are very sophisticated, and they're complex. They're linguistically complex. Some of them they need to be done by linguists, really.
And how does device matter?
The devices enter, for example, in the quality of recordings or pictures. So certain clients have precise requirements around devices, because you can expect that you have a better recording quality from an iPhone or from a certain brand of iOS phone. And the same thing applies to cameras, or videos. So that's mostly because of the quality in the collection.
Thanks.
Thank you. Please.
I'm Asher. In the first slide where you said how the bias gets passed forward, so do you have a way where, let's say...
This one?
This one right here. So for the testing, is there generally a way to trace back to the beginning? So let's say we did a whole training set and now we found something wrong, like the examples you said at the beginning, right? So is there generally a way to go back through and identify why it particularly was wrong?
There is. If you keep versioning of your model and of your data to the model, you can actually understand through the test set that you applied at the level of what happened in that exactly example. Some of the things, for example, again, back to the speech recognition system case, oftentimes it's a normalization. A lot of the times it's a text normalization problem, which is a problem of conversion between basically what you say and the output that can be a cardinal or a Roman number or something like that, or an address that becomes read in a different form. And that changes the whole output completely if you are then introducing that to another input system that's going to read that to, for example, identify sentiment or information extraction. So yes, if you keep that, but believe it or not, it's not that obvious, apparently. A lot of the times, because people are new in the field or are out of college, and in college it's a different world, and you also have a lot less data available, suddenly becomes a maze of versions and data sets and matching to it and architectural problems, and it seems obvious, and it's not. And it's also a problem that engineering-wise is not easy to resolve. All right. If nothing else, I appreciate you. Oh, yep, please, go on. Please forward.
So I have a couple of questions. My name is Ramiz. I'm a data scientist at a company called Grab, which is a ride-hailing company that works out of Southeast Asia. So my first question was, I heard you say simulate. Does that mean it's actually simulating the speech data?
Yeah, it can be simulating speech.
So like adding noise and changing tones and pitch and adding distortion, things like that?
Changing a female voice into a male voice, changing a happy voice into a sad voice, things like that.
Awesome.
Not the content, but changing the quality a lot of the time. So the content is a little more difficult to do, but it's still possible. It's
creating all the variants.
Research ahead.
The data. Okay. So my second question was, it's more around the business side. Of course, you understand the problem and you have developed a company around it. What stops companies like Microsoft, Amazon, Google themselves doing exactly what you're doing?
Oh, sorry, and what was the question?
So what stops like all these big companies who have access to so much data to do this themselves?
You would be surprised what stops them. I mean, there are some of them doing it. Amazon has Mechanical Turk.
Right.
And it's a public service out there. Amazon is an investor of ours as well, full disclosure. The problem with that is that this field, in particular of the data field, is a multidisciplinary field. And companies often focus on, it's difficult enough to hire data scientists with speech NLP vision background. Right. Then there's a whole engineering around that. Product owners, project managers. But you need legal to deal with labor laws across countries. You need accounting and people with finance background to understand payment and how that operates in certain countries, and taxation. You need to understand UX and task design to make sure that the quality of the data collected is going to yield what you want in the beginning. There's a lot of statisticals and mathematics and machine learning as well to blended in the actual people business to make it smart. Otherwise, it's not smart. It's a human resources company. You want people to be looped in only when they absolutely have to, and everything else is done by machine. There's architecture, there's database, there's UX, there's front end, back end, there's enterprise, and there's the consumer side, which is the contributors. Most of the times, and there's liability. There's a lot of liability involved. So these corporations have enough problems to solve, and this is not usually one of them, but it could be. And a lot of them have to take it internally because they're using clients' data, for which we are ISO certified. We are ISO 27001 certified. We can handle data privacy and sensitive data. But it's keeping this machine of multiple and extensible workflows, sophisticated workflows going from enterprise to crowd and back and all the different steps. So you would be surprised that, yeah, why not? They obviously have all the money and resources in the world to do it. But it's a very multidisciplinary, complex area.
So I guess what I'm hearing then is that...
And we work with all of them.
Yeah, you work with all of them. So it seems like your singular focus on the problem is the differentiator.
It's addressing a problem that nobody wants to deal with. It's the non-sexy side of it that absolutely nobody wants to deal with, and people prefer to actually get it done and well done. Trust is a big thing. We are competing. We don't have actually yet a lot of competitors, but we're competing with consulting companies of 20 years plus. Why are we already competing with them? Because we were able to disrupt this industry fast enough with our results and our fast track. It's easier to obviously move when you're smaller than when you're super big, and also when you're focused and you understand the space. I think that's the success ingredient here so far.
Thank you so much.
Thank you. Well, I want to let you go have a drink. So but I'm happy to take more questions, or well, you have, in the end, I mean, if you're a client, there's sales@definecrowd.com. If you are interested in learning more on different capacity, mail@definecrowd.com. Or if you are looking to join this amazing cause, and we are growing exponentially, it's hr@definecrowd.com, and we have a careers site. We're hiring 50 people this quarter, to give you an idea. Thank you very much. And we should have